Hey folks, how's it going? Mr. Murray here, coming to you with a breakdown of the Course 1 Statistics quiz. This was for Cohort A1 for the 2020-2021 school year, okay? So in this video, what I'm going to do is I'm going to be going through this Google Forms quiz. I'm going to be breaking down the answers to each of the problems. And then what I'm going to be doing is I'm going to be talking about things that I saw, things that I think went well, and things that I would like to see some improvement on. I have been getting questions like, hey, can I revise this? Can I retake it? I'm not going to allow that because at this point in the game, this is an honors class. If you're in an honors class, and in general, I don't really do retakes and stuff like that. But here's what I'm going to say. I'd like you to watch this video, develop an understanding of where you went wrong. Okay, because I'm going to give this again to you at some point, not this exact quiz, but this content again, and then this is your opportunity to understand it and do better next time. Okay, I value improvement, but I'm not just going to give you points. I want you to earn it. I want you to show me your learning. That's what I care about. That's what matters to me. Okay, so I'm going to start with this first one here. We got this two-way frequency table. I asked about favorite movie concession and favorite ice cream flavor. So the first question, what percent of respondents like candy and chocolate ice cream? What type of relative frequency is that? So it's 10 people like candy and chocolate ice cream out of 256 people total. All right, you were allowed to use Google Calculator, or if you have a graphing calculator, feel free to do that. You also might want to simplify this to 5 out of 128. You could do that as well. Because again, candy and chocolate. Okay, that's what you get is 0.039. So you could say 3.9%. All right, this is a joint relative frequency. Now, a lot of people said conditional. Okay, if it's conditional, it would not be out of the grand total. Okay, that's the idea about conditional. It's conditioned on a certain statement that makes it so that it's not out of everyone. All right. So for example, in this next one, what percent of respondents like candy given that they like strawberry ice cream? So 12 people like strawberry ice cream. And of those 12, 4 of them like candy, right? 12 people. So you can see I've now restricted. So it's not out of 256, it's only out of 12. 4 people like that, and that's equal to 1/3. And you could say about 33.3%. And this is a conditional relative frequency. So the big thing here where people mess up is they do it out of 56 instead of out of 12. And you see they're just messing up the denominator. So when you see given that they like strawberry, strawberry becomes the denominator. And this is going to be actually in some sense easier to do when we get to conditional probability, which is related to this idea. All right, last one. Write a relative frequency question whose answer involves the fraction 31/73. Now, I did like that people actually got creative and wrote entirely new, like, made-up scenarios. I did intend for you to use the two-way frequency table, but I didn't really make that clear. And so if you did make up another situation completely unrelated, but it actually made sense, you could have still gotten full credit here. All right, and if you'd like me to look at yours again, feel free to let me know if that was you and you feel like you should have gotten more points. So write a relative frequency question whose answer involves the fraction 31/73. So if I'm going to use the table, 73 is the total number of people who like chocolate. So I'm going to come down here and it's going to say, I got to include given that they prefer chocolate. Okay, that sets the total to 73. 31, what percent of respondents like popcorn? Because that's in the popcorn column. So what percent of respondents like, I'm just going to abbreviate this, popcorn, given that they prefer chocolate. Okay, so please, if you need to, go back, rewind, take a look at how I did anything here, and then in a moment I'm going to move on to the next question. All right, next is about socks. So this kind of threw some people off here. So data are skewed to the right. That is not true. That's a common misconception. The skewing is happening on the left. And in fact, if you go down and you look at the statistics, you can see the mean is less than the median slightly. That's an indication that there, yes, is a slight skew to the data. The mean is the appropriate measure of center. That has to be false. And the IQR is the measure of spread. That is true. So 3 is the true statement because the data is skewed. I'm not going to write that. I'm just going to say it verbally. One thing I saw, you got to actually think about the statements you're doing, right? If you say 2 and 3, that is impossible because 2 is for symmetric data and 3 is for skewed data. I even saw, for example, people say 1 and 2, right? Those contradict each other because the idea behind skew is it takes the mean and it pulls it down, right? So what this number is doing is it's taking the mean and it's skewing it downwards. So it's not really an accurate representation of the center of the data. It's not as accurate as, let's say, 10, right? If I do it like this is the center of the data, okay? But if we use the median, this would be the center of the data, okay? So if you think about it, that is making the center of the data, the mean, not as good of a measurement, but it really is because of this number that doesn't really represent the majority of the data, and that is off to the left. So it's skewing the data, it's off to the left, the data's got to be skewed left. And that takes us to our SOCs, right? Shape, outlier. So one thing I loved, everyone got what all 4 things meant. They were able to connect that. I do like the data are skewed to the left. Okay, I'm not going to write complete sentences, but I do really appreciate there was a lot of really good complete sentences, so that's worth praising. There is, yes, an outlier. In this case, you don't need to use a coordinate pair. You can just say 2. That's fine. Center. Now, center and spread was where I had an issue for some people. So please note, for the center and spread, I need to know why you're using the measurement. So you need to reference the shape of the data. Okay, so remember, since the data are skewed, you've got to start with that so that I know why you're choosing this measurement. The median, what measurement are you using? And what is the value? Okay, I'm just going to abbreviate. Now, there's a lot of creative ways people worded it. I said, I know what I really liked. The median of 10 represents the center since the data are skewed. That's fine, right? That hits all 3 pieces. As long as you make a coherent sentence that it clearly explains what measurement are you using, why did you choose it, and what's its value, sentence makes sense, that's fine. That's fine. I'm open to it, but I need to understand the full picture. Write it as if, remember, write it as if it was you on the first day of learning it. You didn't know how to, you couldn't look at a data set and look at it and necessarily fully understand it. But if I had given you precise reasoning, you would have understood it a lot better than if I just said 10, right? What would that have meant to you, right? Think about that before you learned it. Spread, since the data are skewed, you need to use the IQR of, in this case, 11 minus 9. You can do the calculation if you want. That's allowed, represents the spread of the data, okay? All right, so again, rewind if needed to, and I'm going to go ahead and move on. All right, this one, not much to say here. So the idea is you want to do an analysis of the correlation coefficient. The big thing I did not see is it being used correctly in context. So here's what I want you to say in this case. First of all, you need to identify the x-axis, SAT score. The y-axis, calculus final exam score. Now, we look to the correlation coefficient. It's 0.5. 0.5, it's a positive number. Now, one word that I saw someone, combination, I saw a couple people, is weak, strong. Think about if the words actually make sense there, right? Weak and strong, those things mean completely different things. They literally do, right? If you're weak, it's complete opposite of being strong. So those words shouldn't follow each other. So we know the correlation is positive. I know the correlation is positive because this is a positive number. You can see it's going up, right? Look at that line of best fit. It's going up. But it's not very close to 1. So we're going to say there is a weak positive correlation. and we need to bring it into context between SAT score, that's the X value, and calc final exam score. You got to bring it into context, okay? Weak positive, again, weak because it's far from 1. It's 0.5. It's very weak. You can see they're scattered. Positive, though, because the trend, weak as it is actually going up from left to right. And then remember, so what's going to change, right? This is going to change depending on the R value. This is going to change depending on the sign, right? This is going to change depending on the X, and this is going to change depending on the Y. But the statement more or less stays the same. And this, you're going to notice this is a very common pattern in math. These very standard ways of writing things that are basically almost always the same, except you just make little tweaks based on your personal observations, okay? And we'll keep working on it. I know it's super tough. So question 7, people interpreted this in different ways. What I wanted you to do was to consider what the strength of the correlation means about how well a line does at representing it. So you want to tell the department head, no, he shouldn't use the model. And the reason is that because there is this weak correlation, what that means is that a line does not do a good job of representing the data, which means it's not going to make reliable predictions, which means it should not be used as a model. Now, I was pretty lenient in how I graded this one, but that's the idea. The farther away from 1 it is, not only is the correlation weaker, but what that means is because this is a linear correlation. It's saying, are they correlated in a linear manner, right? But what I might have remember me saying this in class, there's all different kinds of ways to correlate data. You could use a quadratic relationship. We're going to learn about that this year. Parabolas. You could use an exponential function. You're going to learn all different kinds of ones during high school. And so what this is telling us is that in this case, no, this linear pattern model is not doing a good job. And also the scattering of the data seems to indicate that there really isn't a strong connection, right? So you doing well in the calculus final exam, right? Yeah, you could have gotten a perfect score and you could have had a great SAT score, but you also could have had almost a 500 SAT score, right? Here, we had someone with one of the lowest SAT scores, and to be honest, people with higher SAT scores, look at this guy, right? This person had a 7, probably 20. They did worse than this guy with a 400. So there doesn't really seem like there's a strong connection there. All right. Last one, this is a social justice context. So what I did is I took the household income of a number of cities in Massachusetts, and I looked at what percent of those households in the cities have a computer in their house, desktop or laptop. So again, type in strength of the correlation. I'm just going to say it verbally. There is a strong, relatively strong, and I'm open to that because it's kind of close to 0.8. So there's a strong positive. I saw a lot of negative. If it's going up left to right, it cannot be negative. If the slope of the line is positive, it cannot be negative. If the R value is positive, it cannot be negative, okay? So there's a strong positive correlation between median household income and percent of households with a desktop or laptop computer. Okay, again, there's a strong positive correlation between median household income and percent of households with a desktop or laptop computer. Okay, I'm now going to use this to predict the percentage of households with computers in a town in which the median household income is 50 grand. I did wish people had used more work in terms of showing me what you're plugging in. What you want to do, so the idea is you have this function right here, not this, and what this is supposed to do is this is supposed to allow you to make predictions. So for example, I think those are 3 0 0 0 0 2 0 0 0 2 x plus 62.479. So what this lets me do is it lets me, if I give it an x value, it lets me predict a y value, right? The idea is to use data that we already have gone out and collected, so we know this is true. We know these facts are true. We've collected them, we've measured them, It's facts, right? And we're using these facts to make predictions about the future, right? Because we can gather data and we know what's happening now, right? But what we want to do is see the future, right? We want to be able to make those predictions. Those are extremely valuable. So I'm going to take this, I'm going to plug in 50,000 because that's an income, that's an X, right? It's on the X axis, so you're plugging it in for X. Okay, so now I'm going to do on my calculator 0.0002 times 50 grand plus 62.479. And I get 72.75%, okay, of households. And this is an interpolation. Okay, so first of all, I just want to double check 0.0002 times 50,000. Yeah, up, but I gotta adjust that. I did plus 749. So I'm gonna do this really quick. So do it again. Plus 62.479. So this would be 72.48. In any case, about 72% of households, and this actually kind of makes sense, own a computer. So if you think about it, if you're living in a district where only 72% of people own a computer, that's going to present some challenges, right? If you want to have remote learning. So you can think about how much different of an experience and how much more or less they might be learning than you and how that might set them up for the future, right? What opportunities that might open or close for them as a result of not having that equal access to technology. All right, so hopefully this was a helpful breakdown. Please feel free to stop by for office hours if you have any questions. But keep it up, folks. Take a positive attitude. And remember, you can do it. Until next time, have a good night.